Hello everyone, welcome to Gate Academy Global channel. How are you guys? Just let me know whether I'm audible or not, whether my video is visible or not. Just let me know. Everyone who all are there, just let me know guys. And then we'll be starting with the topic where I have left in my previously uploaded videos. Okay, I'll be continuing from that only. Okay, so I guess I have covered till logical connectives. That's being understood to you guys. Okay, so we have already covered till logical connectives. Okay, so now I'll be talking about, in this video I'll be talking about implications, related terms, and your different kind of other, like yes, satisfiability. We'll be talking about that. So let me simply write over here logical connectives we have already discussed in the last session. So in this video I'll be talking about what? I'll be talking about implication in detail, a bit detail. I'll be talking about the implication. Okay, apart from that I'll be talking about your related terms related to your implication, and then I will be talking about what? Your satisfiability. Okay, so let's start with implication. What exactly is it? You have already learned it. Okay, you have already learned about it. What exactly is implication when I was discussing logical connectives in my last session which was uploaded. Okay, so let me take it further. So let's start from the scratch. So I'll be telling you implication from the scratch over here. Okay, what exactly is an implication and how does it work? What is its truth table? Let's just let's just rewind everything whatever we have covered till now. Okay, so what's an implication? It's a kind of logical connective we are having. It works like this. Okay, so if I'm having a proposition P and it implies Q, what exactly is going to be truth table? And let's understand as well that how does this implication works. Okay, so let me first of all create the truth table for it. We have P, we have Q, then we have P implies Q. Okay, when will it be true, when will it be false? Let's understand that. So let's say this is false, this is false, this is true, this is true, and false, true, false, and true. Okay, so let's understand over here. Over here it will always be true. It's true, true, false, and true. We know this already about this, that okay, what exactly is going to be the truth table for this. Now the main important point over here is, why do we have it? First of all, we need to understand that. And if you already guys remember, we have already discussed that this exactly this part is called antecedent, and it is called consequent. This is called consequent, or alternatively you can also say, what is this? This is hypothesis, and this is conclusion. Okay, you need to understand this. Okay, so implication operation or implication logical connectives work like an experiment. Let's understand the what is the logic behind it. Let's understand this properly. Okay, disturbance. Okay, so let's understand. So how does it work? I have already told you guys, this is our what? Truth table for this implication. Okay, now how does it work like this, and why do we have true over here, false over here, and true over here? Why do we have it? Let's understand it. Okay, so as I have told you, this definition, this part of it, just understand, because we relate to the common words more than anything else over here. Okay, so let me show you. Suppose I say something like this. Okay, let me just come to the proposition which will be resembling this, which will be representing it, and then we'll be getting to know this properly again. Okay, suppose if I say, if you work hard, then you will succeed. Okay, will succeed. So it's important that you remember that. Okay, for English it works like if and then, as we have if and then in the English, similarly it works over here. Okay, so I have written this proposition over here, and let's say I represent this part, if you work hard, by P, and I represent this part you will succeed by Q. So what does this compound proposition tells me? It tells me P implies Q. Now let's understand when it will be true and when it will be false. See, if you have worked hard, and you succeeded, then you will say, sir, whatever you told me that actually happened, you were correct, you were right. Yes or no? You'll be saying like this. If I am giving you some hypothesis that if you do this, you'll be getting this. Okay, this is the hypothesis. I'm telling you, you need to do this thing. This is the prerequisite, and conclusion will be this. So if you complete the prerequisite, if you complete all the conditions for your hypothesis, and you are getting the desired result, in that case it is going to be true. Yes, it's fine, it's going to be true. Okay, so that's why when I had this true, when I said, okay, let's just create the table again. P implies Q. So when I had this true, this was true, then you were telling me, sir, you were right. What? You worked hard and you succeeded. Then you'll say, sir, yes, I worked hard and I succeeded. Whatever you said was correct. So it's correct. So P implies Q is correct over here. Now, what if you have said that, okay, I have told you this statement, and what happened was you didn't work hard. You actually didn't work hard. Okay, you didn't fulfill this condition which was required for this statement. You didn't fulfill the prerequisite initial condition. You have not fulfilled. Basically, you didn't work hard. If you have not worked harder, then what will happen? Then you may get succeeded or may not get succeeded. It completely depends. Okay, but it will not be dependent upon this part, because you have not worked harder. And what was my statement? My statement was, if you work hard, then you will succeed. And you are not doing this. If you are not doing this, that means by default my statement is correct. Because if you do this and you are not getting this, then I will be wrong only. But if you are not fulfilling the prerequisite condition, the initial condition you are not fulfilling, then you cannot say that, sir, you are wrong. You won't be able to say that, sir, you are wrong because I did this and this was not happened to me. Okay, so if you are not fulfilling it, it is always by default true. That's why whenever we have P as false, irrespective of the fact whether Q is false or true, it doesn't really matter. If P is false, it will always be true, because you have not fulfilled the initial condition. And if this initial condition was not fulfilled, that by default means that you are not understanding this, you have not got this. And if this you are not doing, that means by default it is always correct. If there is some experiment, there are initial conditions. If you are not fulfilling the initial condition, how you can get the final result? That's not guaranteed. You may or may not get the guaranteed result, but it is for sure that whatever we have proposed, the hypothesis, that is by default correct. So that's why this is by default correct. So when will it be wrong? When will be P implies Q false? Only when you said that, sir, I have worked harder. You told me that if you work hard, you'll succeed. I have worked harder, but I didn't succeed. That means I have completed the prerequisite. I have completed the initial situation, condition, whatever was the, initial condition was there, which was required. I did all that stuff, but I was not getting the result you said. That means, sir, whatever you told us, whatever you have said to me was wrong. In that case only, this will be false. When P will be true and Q will be false. In that case only, I'll be having it as false. If you are getting this, if you are getting it for the first time, if you are enjoying it, do like and share, please. Okay, so I hope this is clear. Don't forget to like and share. If you're getting this for the first time, how does it work? So I have exactly told you what exactly is kind of implication. How does it work actually? Okay, it's like similar to if and then in your English. Okay, what is its truth table? We have understood. What do we call P? What do we call Q? We have got this. And then there was a simple example to understand properly. How does we have this? How do we get this truth table? Why do we have false at this value only when P is true and Q is false? Why do we have it at that point only? Okay, so for that we have understood using an example which I have given you over here. I hope you have understood. Okay, so this must be clear. How is it working over here? Okay, so now I'll be talking about what are the different representation in English you may get. Okay, because in English there are different, different ways we can write that. Okay, the implication can be written in different ways. Okay, let's understand. Okay, so let me show you some examples for that. Okay, so one example is if P then Q. Okay, so I'll be writing for P implies Q. Okay, what all does P implies Q? Like for this, what can be written in English? So something like this: if P then Q. Now P represents a proposition and Q represents some proposition. Okay, this is first example. Okay, so this is the first one. Second, Q if P. Q if P. This also means the same thing. That Q will happen if P. For an example, you will succeed if you work hard. I can write it in some other way as well. Okay, so Q if P. Okay, okay. What else do we have? We can also write it as Q when P. This will happen when this happens, or whenever P. Whenever P. All these things represent one and the same thing. I'll be doing some English translations as well, and then you'll be able to realize, okay, how does it actually work, how does it actually give me the output. Okay, for this one, Q whenever P. Okay, I'll be taking the examples as well. Okay, and let's see more examples. P only if Q. Only if Q. Sixth, only Q is P. Okay, only Q is P. Let's take some more examples over here. Only Q is P. What else we can have over here? Okay, I am writing what are the different English representation you can have for the same implication stuff. Okay, yes, Q unless not P. Okay, eighth, I'll be talking about each one of these one by one. Just wait for me. Okay, the next one is P is necessary condition for Q. Condition for Q. Ninth is Q is Q is sufficient condition for P. Okay, oh sorry, something reverse, something in, like, I need to change the order over here. This has to be Q. Q is a necessary condition for P. Over here I need to write P is sufficient condition for Q. Condition for Q. Let's understand now one of these, every one of these. Let's learn these one by one. Okay, if you guys are watching it live, just do comment, guys. Then only you will be able to take its proper benefit, and then only I'll be able to realize, okay, yes, people are watching, and I'll be giving more of it towards you. Okay, I'll be giving more output. I'll be giving it in more different way, interactive way. Then we will enjoy more. Okay, if whosoever is watching it out, okay, if you are watching it live, just do like, share, and comment. Don't forget to comment. Okay, sufficient condition for P. Let's understand how these translates to one and the same thing. Okay, so the example for all of these I'll be taking now. I'll be taking the example for all of these over here. Okay, let's see. So we have if P then Q. We have already learned the example of if P then Q. It was like, if you work hard, then you'll succeed. Okay, it was very simple. P implies Q. P implies Q. Very simple. The next part was Q if P. So Q if P was also similar to that. Okay, Q if P was also similar to that. How? Similarly, if I write something like this. Okay, let's take another example. I will play I will play if I complete my homework. If I complete my homework. So if I represent this proposition by P and this by Q, it means P implies Q. I will play if I complete my homework. That means if I have done my homework, then it will mean for sure that I will play. Okay, I will play. But if I am playing, it's not sure whether it's done or not. But it is sure that if this is done, it will be done. I will play if I complete my homework. Okay, I will play if I complete my homework. This must be clear. Okay, now similar to that, we have this Q when P. I will study when I'll be having new books. When I will be having new books. Will be having new books. Let's understand. See this. So this is the example for this one. I will be giving you example for each one of these, whatever I have written, the 9 parts, the 9 examples in which, you know, this implication can be used in English, general English, how it can come in your daily conversation. Okay, so I have just given you some examples of that, and I'll be telling you example one by one, okay, in English. So see this. I will study when I will be having new books. That means I'll be doing this when, if this condition satisfies. That means this is P. If this is your one proposition and this is the another proposition, then it means P implies Q. If I will be having new books, then I will study. Simply. Okay, this must be clear. If you're getting it, if you're understanding, if you're learning something new, then do like and share. Okay, don't forget to do that. I hope this is clear up to this point. Now I'll move to the next one. Let's move to the next one. The fourth part, exactly similar to what we have seen over here. Peacock dances whenever it rains. Whenever it rains. It means when this condition is satisfies, it usually happens. It usually happens. So again we are having the same stuff. Again we are having the similar stuff. That means P. If this is the proposition P and if this is the proposition Q, then it means P implies Q. It means P implies Q. Need to understand this properly. Okay, it means P implies Q. So this is also clear. Now after this, these are the interesting ones. These are the really interesting ones to know. Okay, how does this work? How does this work? Okay, let's see this. Let me erase this part. Please keep noting whatever I'm telling you for the examples. Okay, for each one of these I'm giving you some example over here. Okay, so P only if Q. Now over here, what does it mean? I will study only if. This is bit different than what we have seen. If Q if P and P only if Q. Like there is a difference. Don't say, sir, you have just changed the order. No, there's a difference of only if and if. I will study only if my cousin leaves. Only if my cousin leaves. Only if my cousin leaves. What does it mean? Okay, what does it mean? See this carefully. If my cousin leaves, will I be studying? That depends. That maybe not. That I may not be studying at that point of time. But this is for sure that if I am studying, I told you that I'll be doing this only if my cousin leaves. That means if this is happening, that means he has left. That means he has left for sure. Okay. So over here also it means if this was represented by Q, this will be represented by Q. then it means P implies Q. Okay, so you need to understand this. Okay, I have just written in the same order, P only if Q. Okay, this was important. So let's understand the next one what we are having. I hope you are getting it. If you are getting it, please comment in the chat box. Okay, and if you are not getting it, do let me know. It's very important, okay, for us to enjoy the session, for us to know whether it's correct or not, whether it's working fine, whether it's going fine or not. Okay, so I hope this is clear till this point. Till this point this is clear. Okay, let me just have a sip of water and then I'll continue. Okay, after this what I'll be having is only Q is P. So there is a good example for this. There is a good example for this to for you guys to understand. Thanks a lot, Divyajot Kaur. Thanks a lot. Okay, it really matters a lot. Okay, so let's understand this. Only Q is P. See, what can be a good example for this? Only Q is P. See this over here. Only friends are allowed at home. Only friends are allowed at home. At home. This is important. This is important. Okay, this is very important over here. Only Q is P. Let's understand how does it work, because I have just given you some, some standards, some examples that, okay, you may encounter some sentences like this. Now you need to understand whether this is Q or P or this is P or Q. For that only I have written like this, and all of these means P implies Q only. You need to understand. So this means P implies Q. This also means P implies Q. How does it work? Let's understand it now. See this. Only friends are allowed at home. Just tell me whether it's correct or not. Just focus over here. If there is a friend, does it mean he is at home? Does it mean he is at home? That he will be in my home? Will it be so? Will it be true? If there is a friend of mine, will it be correct if I say that he will be in my home or not? The answer is no. I'm not sure about that if someone is my friend. But I'm damn sure that if someone is there in my home, he's a friend of mine. I'm damn sure about this. What? If someone is my friend, that doesn't mean he's present at my home. But I'm damn sure that if someone is at my home, then he is my friend. So this part, that means if someone is at my home, then it for sure means he's a friend. Then he is definitely my friend. Yes or no? I hope you are getting this. Then he is definitely my friend. That means this part implies this. If someone is allowed at home, he or she is a friend. So just remember this properly. If you have any doubt, sir, why this not implies this, just understand, if someone is my friend, that doesn't mean he is at my home. If someone is at my home, that means he is my friend, she is my friend. Is it clear, everyone? Is it clear, everyone? So over here again, if this was P, this was Q, then it implies P implies Q. That if someone is there at my home, then he or she is definitely my friend over here. Okay, this must be clear over here. Now another interesting one. Which one? This particular one. This is very interesting. People generally get confused for this. Divyajot, is it clear? Divyajot, is it clear over here? Is only Q is P clear or not? Okay, very cool. Great. Okay, so let me just erase it. You just keep noting down the important sentences over here as well, whatever I am writing over here. Okay, those are the examples, standard example for whatever I have written. Okay, because you may encounter a number of English sentences and you need to identify if there are two parts, P and Q, which one is P, which one is Q. You may be required to identify that. So in that case, it really helps. Okay, that's why I'm giving you exact logic. Why do we have it as P and why do we have the other part as Q? I'm giving you logic as well for that. Okay, along with that. So let me remove this. Okay, let's understand. Q unless not P. So it is quite interesting. Okay, so unless by default involves what? unless by default involves not with itself. For an example, if I say, something like this, okay, Avinash will work unless he is out of town. Unless he is out of town. He is out of town. What does it mean? Avinash will work unless he is out of town. Avinash will be working. Avinash will be working if he is not out of town. Unless means if not. Something like if not. Avinash will work unless he is out of town. That means Avinash will be working if he is not out of town. Something like this. Yes or no? Avinash will work if he is not out of town. It means same. Both the sentences are exactly similar. Yes or no? Both the sentences are exactly similar. Avinash will work unless he is out of town, and Avinash will work if he is not out of town. Yes or no? Yes or no? So that means whatever was there with unless, complement of that, if this is P, I'll write not P implies Q. If you call whatever is there with unless, if you call it normally P, then I will say not of P implies Q. As you can see over here, if this was P, then what is this? This is not of P. You have already seen it. If this is P, then he is not out of town means not P. And if I am just using this, then if, it is exactly similar to this part. Okay, see. Q if P, and I said this is not, so not of P implies Q. Is it clear, everyone? Whosoever are watching live, just tell me. And if you have any doubt, the people who will be watching it in the recorded form, just let me know in the chat. I'll be definitely following it up. Okay, I'll be definitely having a look at whatever is there in the comment. Okay, so I hope this is clear, everyone. Divijot, is it clear? If you're there, just let me know. Okay, is it clear? When I'm writing this thing and this thing, both of these are same thing, and by default with unless I assume there is a not included. Okay, if I convert this to this, that means they are similar. He is out of town unless he is out of town, and if he is not out of town, both are one and the same thing over here. Okay, so that's why I have written not of P implies Q. That's why I have already written not of P, so that when I'll convert it, it will be not P and then not of it, because I have told you whatever is there with unless, I'll take not of that and then that implies Q. So not of whatever is there with unless and then implies Q. So what is it? It is P implies Q only. Is it clear? Is it clear? Just let me know. Okay, I hope this is clear. The last two examples again, very important ones. Let's understand them now. Okay, how does these work? How does these things work? Let's see. If I say, I guess this example is clear to you. Okay, let me just erase this one now. Okay, so let's see this one. Q is necessary condition for P. Q is necessary condition for P. So let's hope for the best that what actually I'm going to write is going to work. For an example, identity card is a necessary condition. It is a necessary condition. Condition for admit in institution. Condition for admit or for entry in institution. Let's understand this. People generally have confusion between these two. What is the difference if I write necessary and sufficient? The things change over here. Okay, let's understand how. If I'm writing something like this, identity card is necessary condition for entry in institution. Okay, necessary condition for what? For entry in institution. Identity card is necessary. Okay, so if someone is having identity card, will he be allowed in the institution? May not be allowed, but that is for sure that if someone lies in the institution, if someone is there in the institution, that means that person is having entry card for sure. Identity card is with him. That means this will not guarantee this thing, but this will guarantee this thing. If someone is having identity card, he will be allowed or not, I cannot guarantee that, but this is for sure that if someone is there, he has got an entry into the institution, then it means he is having an identity card. Yes or no? Yes or no? Just tell me. So that's why I will say if this is P, this is Q, then I will say P will implies Q. Is it clear, everyone? So we have a number of examples where P implies Q will be there. Is it clear to everyone? Whosoever are watching it live, just let me know, guys. Okay, it's important so that we can take maximum benefit of it. Okay, I hope it's clear. I hope it's clear. So let's move further. Let's move further. Okay, see this. If I have, what about this one? P is sufficient condition for, sorry, oh, I have written something. Okay, this has to be Q. Now what exactly is difference, you'll be able to understand very soon now. Okay, see this. If I write something like this, okay, that, what is that? Logo t-shirts. Nowadays people have logo t-shirts. Okay, logo t-shirts are sufficient to allow the entry in institution. Now just understand this thing. Let's understand these. Okay, if you'll be able to understand, then we'll be comparing these two. Then I will be comparing these two. This is very important. I'm taking all the live examples, all the real life examples. Logo t-shirts are sufficient to allow the entry in institution. Let's understand this properly now. Let's understand this. Okay, so what is important over here is there may be a number of prerequisite, a number of conditions for which I may be allowed inside an institution. There may be a number of conditions for which I may be allowed an entry inside the institution. One of the sufficient means that's enough. If someone is fulfilling this criteria, then it's fine. He is eligible. He or she can appear. Okay, that means if someone is having this, then for sure entry will be for sure there. He will be allowed. Yes or no? If someone is having logo t-shirt, then he will definitely be allowed. Okay, this is for sure guaranteed. But can I say if someone's entry is there, someone has taken an entry, he or she is having a logo t-shirt? I can't say that, because for an example I may say that there may be these kind of condition A, B, C, D. Okay, there may be this condition for which I can say entry is allowed. There may be this condition for which entry is allowed. There may be this condition for which entry is allowed. This for which entry is allowed. For an example, if someone, I will tell you exactly what are the necessary and sufficient conditions. Okay, let's say for an example, real life example, if you are BTech in CSE, then it's a sufficient condition to enroll for the masters in computer science. If you are BTech in ECE, then it's a sufficient condition for the admission in MTech CSE. So there are multiple ways you can take the entry, this. So that means if this condition fulfills, entry is fine. I can take the entry. But if I'm taking the entry, whether it is this only which will be there, no, there can be multiple things. So this will not guarantee this, but this will be definitely guaranteeing this. That's why whenever P is sufficient condition for Q is written, it always means P implies Q. Good evening, Manish. Good evening, Manish. I hope you were there on Gate CSIT channel when we were studying mathematical logic from start. Okay, so that means P implies Q. Okay, now what was the difference with the necessary condition? Necessary condition, for an example, your you need to have 60%, more than 60% in your graduation. That's a necessary condition for the MTech. That's a necessary condition for the MTech. But does that mean if you're having 60% in your graduation, okay, that you'll be having an entry? No, that is not guaranteed, because I may be BTech in some other branch, let's say mechanical, which is not allowed, maybe something like this. Or I may be BCom. I may be a BCom person with more than 60%. So 60% is a necessary condition for the admission for MTech. Okay, let's suppose this is true. So if I'll be having 60%, will that be fine that I'll be getting an entry into the MTech? No. If I'm getting an entry in MTech, then I am definitely sure that I will be having 60% in my graduation, because there may be some extra condition with 60% which will imply this. Okay, is it clear, everyone? Is it clear, everyone? Is it clear? How does this sufficient and necessary works? This was the representation for sufficient, that there can be multiple ways I can get to this. That's why this implies this, this implies this, this implies this, this implies this. Or if I say this implies this, then I cannot guarantee which one is true. Similarly, if I talk about necessary, then whatever condition I am having, say A, along with that something extra has to be there for which I can guarantee, okay, the admission is allowed. Sir, we have to take only true examples for P and Q. Yes, dear. Right now we are taking those examples only to understand how implication for these translation works. Okay, for these translation, how does it work? For that only we are just talking about that. Is it clear? Normally when we'll be solving problems, then we'll be talking about whether it will be true or false, or what will be its validity, whether it will be a tautology or contingency or a contradiction. We'll be talking about that later on. First of all, we are just understanding that, okay, what all represents an implication, what all condition means an implication. We are just learning up that. Is it clear? Is it clear? Is it clear, everyone over here? So I hope that's clear. So sufficient means there are a number of conditions and each of these conditions are sufficient for this. So that's why I say this implies this, this implies this, this implies this, this implies this. But I cannot say in the reverse that if this condition is satisfied, that means it was this only. No, there can be any of these. That's why whenever I talk about sufficient condition, it means P implies Q, not Q implies P. Okay. Similarly, when I talk about the necessary condition means if A is a necessary condition, there may be some extra condition as well, which combinedly will make sure I get an entry. So that means if A condition is fulfilled, that doesn't mean I will be having an entry, but it is for sure that if I am having an entry, that means I am definitely having this condition fulfilled. If I am getting enrolled into the MTech CSC, that means I am definitely having my 60% in graduation. 60% in graduation. Okay, is it clear? Are all of these examples clear? Have you guys understood how does P implies Q can be used in different ways in English? In English you may encounter all of these examples, and all of these means only one thing, that is P implies Q. Is it clear to every one of you guys? Just let me know. And who all are watching, please do like and share if you are getting it, if you are enjoying it, if you are getting something extra. Okay, just do let me know. So I hope it's clear. Shall we move forward? So I hope this point is clear. This point is clear. In the next session, I'll be solving the number of problems based on translation. I'll be talking about all these conditions. I'll be taking some gate problems as well based on these kind of situation. You'll be amazed to know you'll be able to solve them like this if you understand these things properly. Is it clear? Is it clear, everyone? Okay, cool. So let's move on to the next part. What we are having, there are some related terms. there are some related terms. Related to what? Related to your P implies Q, related to implication. If I say there is a, proposition, there is a compound proposition. I hope you have seen my previous lectures where it was there. What is compound proposition? What is atomic proposition? I hope you have seen that in English on global channel I'm talking about. Okay, if you have seen that, then this is a compound proposition. So for that, I hope this is clear that okay, this is a compound proposition I'm having. Compound proposition I'm having. So for implication, there are some relative terms. What are those relative terms? Let me just tell you. Let me show you. Okay. There is a term called inverse. There is a term called converse. And there is a term called contrapositive. Contrapositive. Okay. These are the different terms associated with an implication proposition. With an implication proposition. Okay. I hope you remember that. Okay. So these are the important terms. So now what does it mean? If there is an implication P implies Q, then if someone tells you, just tell me the inverse of the implication. If someone asks for inverse of the implication, any implication P implies Q, then you will write inverse as this. Inverse like this. Not of P implies not of Q. If someone asks you that okay, what exactly will be the converse of any implication you are having? So let's suppose the implication you are having is P implies Q. So if I talk about its converse, then what will it be? Then converse will be Q implies P. And if I talk about what will be the contrapositive for any implication you are having, this is the implication you are having. If you are having this implication, what will be the contrapositive of this implication? Then it is going to be not of Q implies not of P. Sorry, not of Q implies not of P. This is important. Not of Q implies not of P. Okay. So I hope this is clear. This is clear over here. Now very important stuff over here. You need to understand that inverse and converse of an implication are equivalent. They are same. And the implication and its contrapositive are exactly same. They are equivalent. Now what does actually equivalent means? It means they are one and the same thing. They are one and the same thing. Okay, that is just different way of writing it, different way of representing it. Okay, let's see how. So if you remember, I have already told you that P implies Q can also be written like this, not of P or Q. If you remember this, just remember this properly. Not of first part, then or, and second part as it is. Not of P or Q. You can write it like this. You must know this. Okay. Not of P or Q. You can write it like this. Okay. You can just solve it by using your digital logic or that same stuff, K maps. Okay. If you have seen the digital, if you have studied Boolean algebra, Boolean expression, you have solved, and you remember K map for the minimized expression. So you'll get to know, if you know the truth table of this operation, whatever we have, just replace true with 1, false with 0. And if you identify the expression for this in digital logic, you will get like this, P bar plus Q. And I have told you that over here in your mathematical logic, there is some similarity with digital logic and set theory. Whatever complement you are having in set theory may complement whatever set theory, the complement in set theory. Okay, negation in our mathematical logic, ML, and the complement, again complement in what? Something like this, or bar we write in our digital logic. These are one and the same operation. In set theory we have a union, in mathematical logic we have this or, and in digital logic we have this or. In set theory we have this intersection. In mathematical logic we have this operation which is and in digital logic we have this product. So you'll be able to get to know that this expression will be coming which is equivalent to this in your mathematical logic. Is it clear? So I have already told you when we studied logical connectives in the last session, if you have already seen, those were very small session. I hope you have already gone through that. Okay. So the equivalent expression for this is this one. Let's find it. Let's find out what are their equivalent expression in common with common logical connectives, because this is a bit a complicated connective, not much, but yes, I can convert it into the simpler connectives. This is the OR connective, this is the negation, so this is a simpler one. Okay, so let's convert each one of these and we will get to know which ones are equivalent. If I talk about the inverse, what do I get? This was not of P implies not of Q. So if I convert this, what do I know? It will be complement of first, that means complement of complement. Okay, or second part as it is, I will be having this, that means P or not of Q. If I talk about the converse, what I'll be having, that was Q implies P. So what do I have for this? Not of first, negation of first, and second part as it is. So see, this is same, P or negation of Q, no negation of Q or P, one and the same thing over here. Okay, and the last but not the least, what about contrapositive? That was negation of Q implies negation of P. So if I write negation of negation or negation of P, what will it be? This will be normal Q or negation of P, which was similar to what we have seen over here. That means your implication will always be equivalent to its contrapositive statement, and implication will always be equivalent to its contrapositive implication or statement. Okay, similarly the inverse of an implication will always be equivalent to converse of the same implication. Okay, for an example, let me just share with you simple example over here. If I say something like this, okay, if it rains, I'll cook pakoras. I will cook pakoras. Something like this. Let's say I'm writing like this. Okay. If it rains, I will cook pakoras. Something like this. Okay. So if I say this is P, this is Q. So let's write its inverse. What will be its inverse? Inverse is simply with negation you will be writing. If it do not rain, if it doesn't rain, I won't cook pakoras. Okay. Similarly, what will be its converse? Converse of this one. That will be, if I will cook pakoras, then it will rain. Then it will rain. Then it rains, or simply then it rains. And what is contrapositive? Contrapositive is, if I won't cook pakoras, then it won't rain. So see, this is very important. This statement is equivalent to this statement because the implication is equivalent to its contrapositive. Okay, so what I have written, contrapositive means not of Q implies not of P. So I have written, if I won't cook pakoras, then it won't rain. Simple. Okay, so contrapositive are same and these two are same. The inverse and converse are always same. If it does not rain, then I won't cook pakoras, or if I will cook pakoras, then it will rain. So these two are equivalent. Is it clear, everyone? Is it clear to everyone? Just tell me, is converse clear? Is inverse clear? Is contrapositive clear? Is implication with detail clear to you guys, whosoever are watching the session? Is it clear, everyone? Is it clear, everyone? Just let me know, guys, in the chat. It's important. Okay, I hope you have got this. Okay, so last but not the least, I'll be talking about the satisfiability as well. Manish, this is not the first class, this is the third session. Earlier I have uploaded the English lectures over here. Okay, so over here on the global channel I'll be only teaching in English. Okay, the medium of the lecture will be only English over here. So I have already uploaded 2 lectures over here, the basics. Okay, so it's not like there is not much difference, only few parts are different. Okay, I'm only ahead by few lectures over here. Okay, not much. So I hope this is clear to you guys. Then at last I would be talking about only a few stuff, small stuff. Let's talk about that. Okay, first point, what's that? Any proposition, any given proposition can be either satisfiable or not satisfiable, or simply unsatisfiable. Unsatisfiable. No, Manish, it's not like that. It's not like that, Manish. It's not like that. So within satisfiable, I have 2 conditions. The proposition is always true. Always true. The proposition over here we have this is always false. Unsatisfiable means always false. And there is a like mid situation also. At least once it's true, and at least once it is false. Okay, so the situation over here we call them as, this one is called what? This one is called your tautology. Over here we call it as contingency. Okay, over here we call it as contradiction. Is it clear? Is it clear, everyone? Just let me know. Is it clear? What I have written is, the proposition can be either satisfiable or unsatisfiable. Satisfiable means it may be true. It must be true for at least one case. So what does it mean? True for at least one case. True for at least one case. If it is always true, then it's a tautology. So at least one true was there, and if it's not a tautology, then it's definitely going to be at least one false. Then that is called contingency. And if not satisfiable, that means it is always false. That's a contradiction we are having. Is it clear, everyone? Is it clear to everyone? I hope this is clear. Very important over here. Is it clear? Anyone having any doubt over here? Anyone having any doubt? Just let me know, guys. Which one you want to ask? Manish, let's not talk in Hindi over here. If you really want to converse in Hindi, we make connect on the other channel, because it's for people who are used to of English only. Okay, so just let me know if you're having any like doubt properly. Just mention. Is it clear, everyone? So contradiction means always false. Contingency means at least one case of true and at least one case of false is there. Tautology means it is always true. Let's say for an example, this is going to be the last part of the today's lecture. In the tomorrow's session, we'll be starting with some English translation and good questions we'll be talking about. Okay, for an example, if I talk about let's say this one, P implies P, what will be its value? Okay, if I talk about Q and not of Q, if I talk about P or Q, Let's just talk about all of these situation. You'll get to know. So if I talk about P implies P, whenever P is true, this is also true. Whenever this is true, this is also true. Whenever this is false, this is also false. So false implies false is always true. True implies true is always true. So if you draw a truth table for that, it will be having only truth values. It will always be true. If you just draw a truth table, you will be get to know that it will always be true. Always true. Okay. Or you can simply, use the other method. What does P implies P means? It means negation of this or this. What is it? If P is true, then it is going to be false. False or true is true always. If this is false, that means this is true. And this is false. True or false is always true. So that means it's a true. It's true always. That means it's a tautology. It's a tautology. A simple example I'm just taking. I'm taking simple examples over here. Okay. Let's talk about this. Let's talk about this. Q and not Q. Q and not Q. Just tell me, if this is true, then this is going to be false. And if this is false, then this is going to be true. And for the AND operation, all the input must be true so that the output can be true. If any one of them is false, then we get a false output. So that means, what do I get over here? What will be its output? Its output is going to be false always. False always. That means it's a contradiction. It's a contradiction. Is it clear? Is it clear? Now let's check for the last part we are having. Let's talk about the last part we are having. That is this one. Okay. So I won't be getting, let's just draw the truth table. Let's just draw the truth table. You'll get to know this. If this is false, true or true, false, true, false, true. What will be my truth table? It will be false, true, true, true. So at least one case of false is there. At least one case of truth is there. That means it's a contingency. What? It's a contingency. Is it clear? Is it clear, everyone? Is it clear to all of you guys? Divyajot, is it clear, dear? Manish, is it clear? So all of you guys who are watching it live, if you're learning it, if you're enjoying it, if you're getting to know something extra, please do like and share. Keep liking and keep sharing. Okay. So I hope this is clear to everyone. So we have completed what we have learned over here. Different satisfiability conditions, satisfiability and unsatisfiability condition. Okay. Tautology, contradiction and contingency. I hope this is clear. Okay. So it's time to go. So thank you guys for being there. Tomorrow we'll be talking about some English translations. We'll be continuing with that. We'll be solving a number of problems based on that. And we'll be considering some gate problems as well. So see you guys tomorrow in the evening at 6 p.m. Till then, bye-bye. Take care. Thank you guys for being there.